Hello and welcome to GitHub Importer overview. This is a GitLab feature that allows you to migrate projects from GitHub to GitLab. You can check more details under these URLs, the user guide as well as the developer documentation. What it does, like I said, migrates GitHub repositories to GitLab as projects and migrates this list of data. Mostly it's, pull requests, issues, labels, milestones, stuff like that, and comments and LFS objects. And I guess the first thing that I would like to show you is the demo. You can go to new project page, import project, select GitHub. This is the page you will be presented with. Authenticate with GitHub, where you provide your token. And this is the page that you're going to be presented afterwards with the list of projects that you have on GitHub. And I have a project here that I'm going to press import. And this project here is just the one file project that I have one pull request on, and I made some comments. I guess while it's importing, I would like to start by saying that there are two types of GitHub importers. The sequential importer and the parallel importer. By default, we have the parallel importer that is used in the UI. But sometimes there's a use case for a sequential importer, and as the name suggests, it imports everything within a single process. For example, the only use case here is import rake task. If you need to import the project through the terminal, it's going to do just that. And the sequential importer is used here. And by default, through the UI, we have a parallel importer. And parallel importer is highly asynchronous. Let me open it up. Yes, it's highly asynchronous, and I will show more detail. But when we execute this importer, the very first, the importer overall happens in different stages. It executes, it imports data in stages. So the first stage is repository. This is something that is the first step for many of our importers. That's the step that we need for in order to migrate merge requests. It's pretty central to our all of the importers. So as you can see here, the parallel importer, it used the job for import repository worker. It does the import, and then the next stage is base data. And base data is essentially this: labels, milestones, and releases. It performs that. It executes every importer for within this job, and then it enqueues pull requests worker. So that's the next stage. And after that, all of these. So we have an advanced stage worker. That's the worker that is used in order to wait for a number of jobs to complete before we go, because prior to the advanced stage worker, all of these workers, as the last step, they would enqueue the next worker. But in case of advanced stage worker, that's no longer the case because of the way we import data. And here's the list of stages that we execute. So the next stage will be pull requests merged by information. And then pull request reviews, issues and diff nodes, nodes, LFS objects, and then we're done. So for example, here's the pull request merged by worker, and it re-enqueues the advanced stage worker and passes the next stage information once all of the jobs have been completed. Although, yeah, it's not necessarily that all the jobs have been completed, but it waits for jobs to be completed, and then it re-enqueues itself. So the main collections worker, it executes an importer, okay, and every importer has this module parallel scheduling. All of the importers across the entire GitHub importer, they all have the similar pattern, which is utilizes inheritance heavily, as well as defines these kind of classes. So there's a number of methods that you need to define and include the parallel scheduling module. And parallel scheduling, what it does is it fetches resource collections endpoint from GitHub page by page. And for every object to import, it enqueues a separate job. So for example, here, each object to import, we fetch that object. We fetch that object here, and then we have the representation class. And each representation class is like a conversion tool, right? Raw data into a hash. For example, here's the pull request representation, and we convert it, we transform it, right? We take that and we enqueue the sidekick worker for each individual pull request for each individual object, whatever it may be. Issue, node, label, not label, but issue, node, pull request, etc. Right? And then we create a waiter for it, and then we return it. And I will cover the waiter later on. Actually, right now. The job waiter is used to keep track of state. If you've seen my previous recordings for import-export, for example, we use database record to keep track of import state. But here we use Redis shared state to keep track of all these jobs. Because if you imagine if you have a project with 10,000 pull requests, and each pull request is a separate sidekick job, and if you have separate sidekick job for every single if you have a separate database record for every single pull request to keep track of its state, obviously that's going to create a lot of noise in the database. I mean, produce a lot of, not necessarily noise, but produce a lot of data, write a lot of data, right, to the database. So yeah, here is the GitLab job waiter. Utilizes Redis for it, and that's how it keeps track of the progress that's been made. You know, the advanced stage worker, it checks this array by the key. If it sees it being empty, then that indicates to the worker that the job is done. If there is something in the array, then it's it knows that it's not done yet. Okay, and every importer, yeah, like I said, every importer class kind of looks like this, where it includes parallel scheduling and defines the importer class. So this is the collection importer, right? But it defines individual importer, an individual object importer, the representation class, the sidekick worker class, the collection method. This is the method that is used to fetch data from GitHub, and so on. You can have a look at the parallel scheduling. I mean, at first it is kind of difficult to grasp and navigate, but over time it becomes easier to locate certain bits of logic that you're looking for. And something is wrong with the import, but that's oh no, never mind. I was worried that something might be up for with my local environment, but it completed. So we have this project here with a merge request, and we have this merge request with a few comments, I believe. Yeah, so we have a regular comment, diff comment, and review comment. Regular, diff, review comment. So that's like the basic idea behind this importer. Bulk insert. So unlike import export, where we for everything that we insert into the database, for everything that we save, we run active record callbacks, except for a few exceptions. But the overall is that all of the callbacks are running. We never skip anything. Well, almost anything. In GitHub Importer, that's the opposite actually, because well, primarily for historic reasons, that's how it's been reintroduced, but mainly yeah, because there might be tens of thousands of nodes, and in order to release the database from additional pressure, we bulk insert. And here's the example of diff node importer, where we format the node and then we use bulk insert to insert these attributes. I guess the main difference between this and import export is that import export has a lot more nested associations. You know, like you can imagine a merge request with nodes. Inside of nodes, you have award emojis, user references, system node metadata, events, whatever it might be. It can be a bit of a bigger package, I suppose, to what we fetch from GitHub API. The data that we receive from there is quite flat, and perhaps it's a bit more safe to insert it using the bulk insert functionality. Now, you may have noticed that the advanced stage worker has these two stages: pull request merge by and pull request reviews. Like why are they needed? Why not just have them as part for, like, let's say node diff nodes, right, or nodes? And the main reason is because these are separate API endpoints that are coming from GitHub, and they do not have individual records. They only have individual API endpoints and not collections. So for every merge request, let's say we imported 10,000 merge requests. For every merge request, we need to go back and one by one fetch all of them merged by information, which can be quite slow. So yeah, it does not have the collection API, so we have to fetch MRs one by one, which is not efficient. It's just the way that GitHub exposes their data, and that's what we have to work with. So mainly these are the stages that you have here. Obviously, so we have the issues and diff nodes combined. So we have the issues importer together with diff nodes. Yeah. I guess another thing worth noting is object importer. That's another module that is being used to execute individual imports for individual objects. So yeah, like I said, I'm not going to go through all of them, but these are some of the pointers that can be useful when it comes to understanding GitHub Importer better. Because yeah, it's highly asynchronous and it can be a bit of a challenge to navigate through this code base. Also, the last thing I wanted to touch on is the single endpoint nodes importer. What is that? So single endpoint diff nodes importer. You can see this is the diff nodes importer, and we have another the regular diff nodes importer, right? What's the difference? Well, the difference is this. Let me just open them side by side. And if you take a look at the collection method, this one uses pull requests, plural, pull requests comments versus pull request comment. So, which indicates that this method of importing fetches diff nodes comments one by one, MR by MR. Okay, MR number one, give me all the comments. MR number two, give me all the comments. While this endpoint returns all the comments across all of the merge requests, right? So you don't, like, it's convenient because you have one endpoint, but you need to sort which diff node belongs to which merge request yourself, and that's what we do during the import. And so the question is, why do we need this one? And there's one big reason, and that reason being is GitHub API limitation. For instance, if we open this URL, which is issues, comments of this project, page 401, it will tell you this. In order to keep the API fast for everyone, pagination is limited for this resource, meaning that you simply cannot fetch all the available comments for this project. And this is the Node.js project, by the way. So we stumbled upon this problem somewhat recently, where an import was missing comments, and after a lot of digging around, we found that GitHub API just simply does not return all of the comments that there are. So we had no choice but introduce an alternative way of importing nodes to the GitHub importer, and this way fetches them one by one, right? Which is way slower, but that's the trade-off. If let's say you have a massive project, you want to import all of the comments, and the current approach does not provide all of the comments, then an alternative solution is to try this way of importing. And this issue is behind two feature flags. Number one is the single point endpoint nodes import, which changes the way we import nodes. And the other one is the lower per page limit. And that's another GitHub limitation, where sometimes if you fetch a page of default page number 100, GitHub will return 500 error and will not return the result. So another feature flag was added to just reduce the page number, the page size, in order to try and help with stability and try and fetch all the data there is, even though the price is speed. So we have a single endpoint diff nodes importer, single endpoint issues nodes importer, and single endpoint merge request nodes. Yes. So that's the high-level overview of GitHub Importer. Like I mentioned, it's highly synchronous in parallel mode. I guess the main point of the main module is parallel scheduling in order to understand how it works. But yeah, it's mainly one job per object. Keeping state, keeping track of state in Redis, and using the job waiter as a way to keep track of all these jobs. That's it. I hope this was useful and you have a bit more clarity when it comes to how GitHub Importer works. Thank you.